Hello and welcome back. Today we've got a very exciting tutorial. We're talking about how a transformer generates text, and we're talking about the full transformer architecture. So here we've got our full transformer architecture, and in the upcoming tutorials we'll talk about the nuts and bolts of how it all works together. But for now, we'll just get a bird's eye overview of how it generates text on a conceptual level, and this will really help us in the upcoming tutorials. So let's put this in the middle, and we're going to be looking at a translation example. That is because the original paper, Attention is All You Need, was created for a translation use case, and I picked the languages English and Slovenian at random. I'm no expert by any means in Slovenian, and the same principles would of course apply to any other language. So we're going to be looking at this during inference, and we'll talk about training in upcoming tutorials later down in this section as well. Now, the sentence we're going to be translating is, "This boy likes to learn." And here we go. So the first thing that happens is this EOS token gets added to the end of the sentence, and EOS stands for end of sequence, and it signifies to the transformer where the input stops. So all of that gets put into the input, and it goes through all of that gets put into the encoder, and it all goes through the encoder, and it sits there at the top. We've got this encoder output. So again, we'll talk more about these, the technical details of this in upcoming tutorials, but for now it's important to understand, very important to understand, that the input we put into the transformer goes to the encoder only once. It goes in and then it sits there at the end of the encoder. Well, we have it, like I say, metaphorically speaking, it sits there, but we have this encoder output and then it's used multiple times, as we'll see just now. So the encoder has generated its output. In the meantime, what's happening in the decoder is we need to generate this output, right? This sentence. And at the beginning, we don't have any output generated yet. So over here, as you can see, it says you need to input the outputs, right? So whatever is coming out of here will then be going back into here. But right now, we don't have any outputs yet. We don't, unlike a large language model, we don't have a prompt to put in here. So what do we put? Well, that's where the start of sequence token comes in for the rescue. As you can see here, it says outputs shifted right. So shifted right is facilitated by this start of sequence token, which when we don't have anything yet here, it gets put in here as a placeholder. You can think of it as a placeholder. So it gets put in here, it goes into the decoder, then it goes through the decoder. It gets combined over here with, so here there's some self-attention happening. Obviously, there's only one token, so there's not much interesting happening here. But then here, it gets combined with the encoder output. That's where the encoder and decoder get connected. This part is called cross-attention. We'll definitely talk about it in more detail coming up. And then it keeps going, and then we get the output probabilities, and that gives us probabilities for all of the words in the Slovene language. And then we pick the word with the highest probability, and that's going to be our output. So there's the word ta. Next, we're going to fade that, step one. Step two is now both of these tokens get taken in by the decoder. They go through the decoder. Again, they get combined with the encoder output, which hasn't changed. It's been run only once. Remember, this part runs only once. So they get combined with the output of the encoder over here, and then that allows us to come up with probabilities for all of the words of the Slovene language and take the one with the highest, predict the next word, font, which means boy, I believe. Then again, that happens, we take, for the third step, we take all of these tokens, they go through, that gives us the next word, and so on. And then again, all of these words. So it generates one word at a time in this like iterative fashion. And it keeps doing that until we get to a point where the next token that's generated is the end of sequence token. So as all these other words, and including the start of sequence token, the end of sequence token is also part of the Slovene language vocabulary. And when these probabilities are assigned, the end of sequence token always gets some probability as well. Just here, its probability was very low, so it wasn't selected as the word of choice. But at this point, at the 6th position, it had a very high probability, and so it was selected as the correct output. And what that resulted in is that now the transformer knows that it has generated all of the translation and that it should stop here. So the end of sequence token signifies to the transformer that it should stop. So there we go. That's how the full transformer architecture translates text. A key important conceptual thing to take away from this tutorial, if we were to take away just one thing from this tutorial, the key thing is that translation, just like any other task that the transformer performs, is a language generation task. It's a one step at a time kind of task. So it's generating one word, it's generating these words, very similar to the decoder only models that we talked about, where we just had the decoder part and it was a large language model where we'd put in a prompt and we'd get some text being generated. Very similar to that. In this case, the difference is that we have this encoder, and we'll talk about how that affects the generation, but ultimately it's still a language generation task. Even though we see it as translation, the transformer sees it as a language generation task. And some additional points. The encoder intakes all of the words available in the input at once. The encoder processes the input only once, very important. The decoder generates only one word at each step, and we take basically it creates probabilities for all of the words in Slovenian language, but then we take the one word with the highest probability, and that's the word that will be generated. And also, like the encoder, the decoder intakes all of the words available in the output at each step. But the difference here is that this happens only once. It takes all of them as input and happens only once. This happens at each step. It takes whatever is available in its input as the decoder. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.